So this is a matrix. We need to prove that, okay, without expanding. Of course, without expanding, we have to prove that this value is 0. So here what you'll do, you see here this 12 minus 5 is 7 and 20 minus 73, so 50 minus 13. So what will do that, this is R1, R2 and R3. That means correct. So this is, so what will operation will do here is uh, new R3 will be R3 minus R2. Okay, so with this operation, if we do that, then what will get it, 2, 3, 7 and 13, 17, 5. Here you will get 15 minus 13, 20 minus 17 and 12 minus 5. So once you do this operation, so what we will get here is now this new matrix 2, 3, 7, 13, 17, 5, and again you will get 2. So you know that, so in that case, if these two rows become same, this row and this row become same, so of course determinant will be 0. Why? Because next step, if we apply this minus this minus this and this minus this, so it will be, all will become 0. So if the two rows become same, so determinant become 0. So this is the way you can prove it. So this is the determinant and we have to prove without expanding this is 0. So we have to find some way so that rows or column operation that will give 0 elements. So here if you observe very carefully, here this is a multiple of 4, this is 4 and this is also 4. So if you divide by 4, it will be 2. If you divide by 4, it will be 3. Divide by 4, it will be 4. So you see that these two column became same. So that means this matrix we can write 4. If you take common, so 2, 2, 7, 3, 3, 5, 4, 4, 3. So now this minus this will give 0, or this two column or two row it becomes same in any matrix. So this matrix end up with matrix value become 0. So as these and these two columns become same, so this matrix value will be 0. So here we have to prove that without expanding this value of matrix is 0. So if you observe carefully that this minus 3 into 2 is minus 6, minus 1 is minus 2 and 5 to 10. So that means if this column C3, if this C3 goes through operation of C3 into C2, okay, so then we'll end up with a matrix 6, 2, minus 10, and here minus 3, minus 1, 5, and by this operation it will be minus 6, minus 2 and 10. Okay, now if you observe it, okay, so now if you okay, after this, if we go through C3 will be C3 plus C1, okay, and then we'll end up with 6 minus 3, and these pluses, 6 minus 6, 2 minus 1, minus 2 plus 2, minus 10, 5, so 10 minus 10. So this column became, all of them become 0. This is also 0, 0, this is 0, so this determinant value is become 0. See, this is the determinant, and we need to prove that without expanding the value is 0. So you observe it here. What you do, plan is to multiply with a with uh, with this row. So a multiply b with this row b, and multiply c with this row. Okay. So then what it will give this row is, this will be 1 aq and abc, 1 bq abc, 1 cq abc. Now if this abc is taken common, so this will get 1 1, so abc you take common from here, so you will get 1 1 1 aq bq cq and 1 1 1. So that means two columns are same. Now if you subtract one from another, so you will get one column as 0. So hence it is proven this determinant value is 0. This is a determinant. We have to prove that value of determinant is 0. So in this case, what you will do, that if you observe very carefully, this minus this will give a, this minus this will give a, this minus this will give a. That means column 3 C2 new will be C3 minus C2. This is one operation. So you will get a and a. Same way, this column, if you say is C2, also new C2 will be C2 minus C1. So this also will get a and a. So hence after that, if you subtract these two, you will get a total column itself is 0. So hence it is proven the determinant will be 0. This is the determinant given, and we have to prove without expanding this value of this is 0. So here what operation we will do, we will do see row 1, new row 1 will be say r1 minus r2. New r2 will be there, say r2 minus r3, and new r3 it will become say r3 minus r2. Okay, so then what will happen is that if you subtract this thing, so here let us do that. So if this minus this, if we subtract this one, so we'll get 0 here first, and this will get a minus b. Here we will get a square minus bc minus b square plus ac. Then here this operation will give 0, and this will give b minus c. Here it will give b square minus ac minus c square minus ab. And here again, if we do this minus this, so you will get 0 here, c minus b, c square ab minus b square ac. So now we see that one of the column is become 0. So this determinant will end up 0. This determinant, without expanding, you have to prove this value of determinant is 0. So yeah, though it is not, so you have to think it in a different plus, minus, multiplication, combination, and all these things. So these are the tricks of this thing. So here, if you observe it here, if you multiply by 8 here, 8 and 8, that means with this on. So then see that it becomes 48, and then 49 minus 48 is 1. So this is the trick. So you are multiplying with 8. So then uh, what have to write? You are multiplying with 8, correct? So your writing still should be 1 by 8, because you are introducing 1 8 here. So 49, 1 and 48. 39, 7, 8 for the 32. 26 to 8 3 24. So next operation is column C3. New column C3 will be C3 minus, okay, sorry, or put, simplify, C1, new column C1 minus C3. Okay, so these one you will get 49 minus 48, you will get 1 here. 32, 39 minus 32, you will get 7 here. 26 by 24, you will get 2 here. So these two column become same. So two columns same means your determinant value will be 0. So this is the matrix given. We have to show without expanding this value of matrix is equal to 0. So if you observe very carefully, this matrix is a little different one. It's a leading diagonals as 0. Okay, and this is actually mirror with the negative. So leading diagonal elements are 0 and mirror with opposite side. Okay, so this, with these two properties, this kind of matrix leads to the result 0. So this is a determinant given, and without expanding, you have to prove the value of determinant is 0. So it is what one property, if you observe it here, you know that any square values, 4 square minus 3 square, how much will be 4 plus 3. Okay, so with that, if we can let's see that if this minus this and this minus this, so like column C4, column C4 is C4 minus C3. So and same time C3 equal to C3 minus C2, C2 is C2 minus C1. If you do that, let's try it, then we'll modify if it is not working. Okay, try. So this, okay, so this, so 2, it will be 3, and it will be 5, 4 plus 3 is 7, and 4 plus 5 9. Here will be again 5, 7, 9, 11, and last one will be 7, 7, 9, 11, and 13. Okay, so let's see what can be done most. Take a pause, think it, and let's come back. So hope we have got the solution. See what we do. If this minus this, then what will happen? 2, 2, 2, and here we will get 4 plus 3, 7. Okay, let's continue and let's see what we get out of this. So what we'll do, this minus this, okay, and this minus this, so we'll continue this way. So this became 1 and 3, 5, 7. This became 4, 5, 7. Okay, so this minus this equal to minus this means what we'll get, 2 square minus 1 square is we'll get 3, 2, 2, 2. Here is also we'll get 5 and then 2, 2, 2. Here we'll get 7, 2, 2, 2. So what can I do with this one? What we can do, so we can repeat the same here. This minus this, so let's see what we'll get. We'll get 0, 0, 0, 2, 0, 0, 0, 2. Okay, and then if this minus this, so 0, 0, 0, minus 2. Okay, and 1, 3, 5, 7. Don't know if does it make any sense or not. So what we'll do here now, okay, we'll continue the same process. I think we are almost there. So whatever it happened, keep it like this, minus 2, 0, 0, 0. And so this minus this means what will happen? Say okay, these also will not do anything. So this minus this means 0, 0, 0, 0. So one of them, one of the row became itself 0. So it is 0. I think there could be some other way to prove also to make it more easier, but okay, as of now I can think of this.